discussing one of the important topic today, which is the measurement. Measurement plays a very important role in the calculation of the physical quantity. If we calculate any physical quantity, then we measure that quantity. So, in physics, to measure any physical quantity, we use the measurement, and the error is also with the measurement. So, in today's topic we discuss the measurement as well as the errors occur in the instruments. So, correct measurement are a key factor in any manufacturing unit. So, without a good understanding of the requirements and the rules, error may occur as a result of incorrect measurement. So, there is a great challenge that whenever we measure any physical quantity or any quantity, then we just use the correct measurement. So, this section introduces the basics of measurement system. So, measurement, what is this measurement? Measurement refers to the numeric expression of a manufactured object dimensions based on the fixed reference, and that will be defined by the some unit. So, measurement, but through the measurement we can find out the object's dimensions, and it in the form of the units. Simple explain, if we simply explain, the dimensional measurement is the comparison of the measurement target against in the reference object. Means whenever we do some measurement, then we take some reference to do the measurement. Now, the reference object is the measuring instrument. So, we require some instrument to measure the any quantity. So, that will be the reference object, and there is a wide variety of the measuring instrument that offer the different measurement purposes, methods and accuracy level. Whenever we just perform the experiment in the laboratories, then we measure the reading, then we measure the, then we all the experiment just give the physical quantity, and the physical quantity, that physical quantity must be represented by the some unit. So, that unit we will measure through this reference object. Now, it is possible to inspect whether the manufactured object fit the required specification by correctly measuring the object's dimension. What we are manufacturing, how we calculate that what device we prepared is the right device, then we just measure its dimensions. And in other words, performing through the measurement is one of the basic rule of better manufacturing. By measurement we can, if we have any error, then we can correct that error and we can improve the manufacturing through the measurement. So, measurement is the process of comparing an unknown quantity with a known quantity. In the measurement, we are having a known quantity and we compare the unknown quantity with the known quantity, and assigning a number to a characteristics of an object or an event. Then we can define that what is the characteristics of that object or the event or the thing that we are measuring. So, the number obtained is called the magnitude of the quantity, and it expressed in the numbers or in the units. So, whenever we measure any physical quantity, then we represent it in the form of the number or in the form of the unit. So, measurement is the process of comparing an unknown quantity with a known quantity and just assigning a number to a characteristics of an object or an event. A systematic organization and analysis are more important for the measurement system. So, the whole operation system can be described in terms of the functional elements, the functional element of the generalized measurement system. You see here on the screen that we have a system, that is a generalized system for the measurement. Now you see that there is a input quantity to be measured. So first what we have the detector transducers stage, where what we have the primary sensing element which take the input quantity which to be measured. So first we have the primary sensing element. Next is a variable conversion element that comes under the signal conditioning element. So first is a variable conversion element, next is the variable manipulation element. Then after that this goes into, that is an intermediate state. First is a detector stage, second is the intermediate stage, and third is the terminating stage. So the in between that is the intermediate state which contains a variable conversion element, variable manipulation element, and data transmission element. After that just the terminating stage comes. That stage is the data presentation element. Means just we give the input which is to be measured. After that there is a processing, then after that there is a output, that is in the form of the data presentation. That data may be stored. So there is another column is there, we can store the data, that is the data storage and playback element we will keep in between the data transmission element and the data presentation element. Now most of the measurement system consists of the following functional elements. Like number one, there are the many functional elements that can be used for the measuring of any system. So first is the primary sensing system that we have discussed, variable conversion element, third is the variable manipulation element, fourth is the data transmission element, fifth is the data storage and the playback element. After that the last one is the presentation element, in which we present the data or we just display the measured quantity. So one by one we will discuss. First the primary sensing element, that is the quantity under measurement makes its first contact with the primary sensing element of measurement system. In this the quantity is the first sensed or detected by the primary sensor which to be measured. Next step, the detected physical quantity signal is converted into an electric signal by the transducers. So transducers is defined as a device which converts a physical quantity into an electrical quantity whenever we measure the electric signal. So we use the transducers which convert the physical quantity into the electrical quantity. That is the first primary sensing element. That sensors we use for that, the sensors is act as a primary element of the transducers. So in many cases the physical quantity is directly converted into an electrical quantity by these transducers. The first stage of the measurement system is known as a detector transducer stage. Example of this type of stage is the pressure transducer with the pressure sensors, temperature sensors, sensing sensors means gas sensors, humidity sensor. They are the various sensors which are used, that are the transducers. Next is the variable conversion element. This output of the primary sensing element is the electrical signal of any form like the voltage, frequency or some other electrical parameter. So output of the primary sensing element that we are getting after the conversion through the transducer, that are the electrical signal. That electrical signal may be of any form like voltage, frequency or current or any electrical parameter. Sometimes this output not suitable for the next level of the system. So it is necessary to convert the output in the some other suitable form while maintaining the original signal to perform the desired function of the system or without change of any value. So, for example, the output primary sensing element is an analog form of the signal, and next stage of the system accept only the digital form of the signal. So, what we do, just we have to convert the analog signal into the digital form by using a AD converter. This AD converter is act as the variable conversion element. So, the next step after the sensing, we use the variable conversion element that will convert the DC current to the AC current or AC current to the DC current, that we will accordingly keep it. Next is the manipulation element. The third phase is the variable manipulation element. The function of the variable manipulation element is to manipulate the signal offered, but the original nature of the signal is maintained in same state. So, hence the manipulation means only the change in the numeric value of the signal. In the variable manipulation element, we have only the change in the numeric value of the signal, but the original nature of the signal will be maintained. Next is the example. If we take this type of variable manipulation element, is the voltage amplifier, is act as a variable manipulation element. Voltage amplifier accept the small voltage signal as an input and produce the voltage with a greater magnitude, and here the numeric value of the voltage manipulation is increased only. Voltage magnitude will increase. So, it converts it just to change the numeric value. Next is the attenuator. In the same, we have the another example is an attenuator which act as a variable manipulator element. What is action? It accepts a high voltage signal and produces the voltage or the power with the low magnitude. Sometimes we require the low magnitude signal, so we use the attenuator as a manipulation for the manipulation. So, here numerical value of the voltage magnitude is decreased. Next is the linear process manipulation element, where we have the amplification, attenuation, integration, differentiation, addition and subtraction of the data. Non-linear process manipulation element, similarly here we have the modulation, detection, sampling, filtering, chopping and clipping, etc. These all are the linear and non-linear processes that is used for the manipulation, variable manipulation detector. As in the linear, we can have amplification, we have the attenuation, integration, differentiation, while in the non-linear, we have a modulation, we have a detection, sampling, filtering, chopping and clipping. So, this is the third type. All these elements are performed on the signal to bring it to desired level to be accepted by the next stage of the measurement system. So, when we get the manipulated signal, then we just pass to the another element, another system. So, another stage will accept this manipulated signal. This process of conversion is called the signal conditioning. So, the combination of the variable conversion and the variable manipulation elements are called as the signal conditioning element. These both combined as this convert the signal from amplify, and next is the variable conversion, and after that the variable manipulation. First the data will convert into the desired form, after the data will be manipulated according to the requirement just to pass to the next stage. What is the next stage? Next stage is the fourth one, that is defined by the data transmission element. What is the function of this element? This element of measurement system are actually physically separated. It becomes necessary to transmit the data from one to the another. The element which is perform this function is called the data transmission element. Basically, transmission means it transmits the data from one end to the another end. So, as the name suggests, so we use this element to transfer the data from one stage to the another stage. So, fourth one is the data transmission element. If we take the example of this, we can take the control signals are transmitted from Earth station to the spacecraft. by this telemetry system and using the radio signals. The telemetry system is act as a data transmission element. Through telemetry, the data will be transmitted from Earth signal to the spacecraft. So, this is the example of the data transmission system. So, the combination of the signal conditioning and the transmission element is known as the intermediate state of the measurement system. As we know that this signal conditioning and the transmission element, we will get the desired output, and this is an intermediate state where we can get the actual measurement, the data. So, this actual data will be used for the output. Now, you see the next stage, that is also the output stage, where we can store the data, and whenever we require we can play that data, we can use that data. So, fifth one is the data storage and the playback element. Some application requires a separate data storage and playback function for easily rebuild the stored data based on the command. Means what type of measurement we are doing, on the basis of that we separate the data storage as well as we use the playback function. So, data storage is made of the form of the this type of digital recording, or like a pen drive, or there another example. Sometimes we use the magnetic tape, we use a recorder, we use the reproducer, XY recorder, XT recorder, optical disc recording. Like that, we have a many recording system so that we can store the data and we can replay this data. The last one is the presentation. That is the most important part, the output what we are getting from that physical quantity. So, data representation element. This is the sixth one. That is the function of this element is the measurement system is to communicate the information about the measured physical quantity to the human observers, or to present it in an understandable form for the monitoring, control and analysis purposes. Basically, this is the output. This is the measurement quantity, physical quantity that we are measuring, that will be recorded and that will be just presented towards the, either it in the form of the graph, either in the form of the number, either in the form of the digital value, or it is in the form of the other form. We can get the data presentation element. So, visual display devices are required for monitoring a measured data. As these devices means we are getting the output as somewhere. Sometimes we record the reading by hand or by this display unit, but there must be a visual display so that we can get the value. Nowadays we are having a digital instrument, so we are having a digital display. Like in ammeter, voltmeter, you can see that we are having a digital display, so we can measure, or we have a visual display, and that devices are required for monitoring or measure the data. These devices may belong or digital measurement like ammeter, voltmeter, camera, like CRT, like printer, analog, or the digital computers. These are the data presentation element. Computer are also used for control and analysis the measured data of the measurement system. The final stage of the measurement system is called the terminating stage. So, we are having a 6 stages where we can get the measurement system properly in an electronic gadget or in any devices. So, what are the characteristics of the measuring elements? Measuring instruments that through which we are measuring the value, or we are calculating the physical quantities. The performance characteristics of the instrument are very important in their selection. There are the 2 type of characteristics of the measuring instrument. First is the static characteristics. This static characteristics, and second is the dynamic characteristics. These static characteristics of an instrument are considered for the instrument which are used to measure an unvarying process condition. Unvarying means which are not changing, which are static, which are fixed. So, static characteristics measure an unvarying process condition, and the performance criteria based upon static condition represent the static characteristics. The static characteristics are the value or the performance given after the steady state condition has reached. Means when we are having the fixed value or when the condition is completed or we are on the steady state condition, then we can get the static characteristics. Next is the dynamic characteristics. This dynamic characteristics of the instrument are considered for the instrument which are used to measure a varying process condition, like the changing conditions that we can measure through this dynamic characteristics. So, performance criteria based on the dynamic relations represent the dynamic characteristics, means it is changing accordingly and then we measure these values. So, we are having two characteristics for the measurements. First is the static and second is the dynamic characteristics. Basically, static characteristics are further divided into many parts. Like when we are calculating the static data, just we calculate the accuracy of the system. So, what is this accuracy? Accuracy is the one type of the statistic characteristics which is defined as the degree of closeness with which an instrument reading approaches to a true value of the quantity being measured. That is the accuracy. In general terms, then we can just you give the accurate value. Accurate value means closest value of the actual value, that is the accuracy, and it determines the closeness of the true value of the instrument reading or the accurate reading of the instrument that is performing the experiment. Accuracy is represented by percentage of full scale reading or in terms of inaccuracy or in terms of the error value. For example, if we take the accuracy of the temperature measurement, instrument might be specified by the plus minus 3 degrees centigrade. So, this accuracy means the temperature reading might be within the plus or minus 3 degree deviation from the true value. So, accuracy is very important just to measure the static characteristics. So, accuracy of an instrument is specified by the plus minus 5% for the range of the 0 to 200 degrees centigrade. In the temperature scale, mean the reading might be within the 0 to 10 degree of the true value. That is accurate value, just as close to the true value, not the exact value. Next is the precision. Precision is the degree of repeatability of a series of the measurement. Means when we take the one reading, then we take the same reading again by the same instrument. So, repeatability of a series of the measurement. So, precision is measure of the degree of closeness of the agreement within a group of measurements are repeatedly made under the prescribed condition. So, precision is used in measurement to describe the stability or reliability of the reproducibility of the result. That we will discuss in the next lecture, like the comparison between the accuracy and the precision. Thank you very much.